So for WebAssign 9a problem 10, it says a proton is projected in the positive x direction into a region of uniform electric field E is equal to negative 6.9 times 10 to the fifth newtons per coulomb at t equals 0. The proton travels 8 centimeters as it comes to rest. So, sorry, if you can hear my dad, just ignore him. He's watching the football game. Anyways, determine the acceleration of the proton. So the hardest part for me was figuring out where to start with this problem, because after that everything is pretty easy. So we know that the net force is equal to ma, and from this unit we also know that the net force is equal to Q times E. So we know that it's a proton, so we have the mass and the charge, and it gives us the electric field right here. So all we need to find is the acceleration, which is what it asks for. So it's 1.602 times 10 to the negative 19th coulombs times negative 6.9 times 10 to the fifth newtons per coulomb equals 1.67 times 10 to the negative 27th kilograms times A. So then it asks for the magnitude and the direction. So the magnitude is 6.62 times 10 to the 13th meters per second squared. Sorry, I don't know what's going on with my pen. Okay, there we go. So we see here that the electric field, it's negative. So I drew a picture to help me figure out the direction. So we have the electric field lines pointing in the negative x direction, and then we have our proton, which is being projected into the positive x direction. So we know that electric field lines point towards negative charges. So if there's a negative charge somewhere over here and the proton is going this way, it's going to be attracted to that negative charge. So it's going to be slowing down because it's being projected this way, but there's a force going this way that's attracting it to the negative charge since it's a proton. So it's going to be slowing down. So then the acceleration is going to be in the negative x direction. Then it asks, determine the initial speed of the proton. So for this, I just used kinematics. So I have v squared is equal to v naught squared plus 2a delta x. So the final velocity is 0 because right here it tells us that it comes to rest after 8 centimeters. So I'm going to isolate the initial velocity because that's what we're looking for. It's equal to 2a delta x. So then I'm plugging in everything we know. The acceleration, we're going to put in a negative 6.62 times 10 to the 13th meters per second squared, because up here it says it's pointing in the negative x direction, so it's going to be negative. This is just the magnitude that we're going to use. And it would also make sense because then these are going to cancel out. Because then when you take the square root, it has to be positive number, or else it would be an imaginary number. Okay, then we have 0.08 meters. Remember to change this to meters, because it gives it to you in centimeters, and that would give you the wrong answer if you didn't change it, because this is in meters too. Then after solving, I got 3.25 times 10 to the 6th meters per second. And it also asks for the direction, and the direction is in the positive x direction because it's still moving this way. Even though it's slowing down, it's moving in the positive x direction. And velocity is displacement over time. So the last thing that it asks is determine the time interval over which the proton comes to rest. So I just used acceleration equals change in velocity over change in time, and I solved for time. So I got t is equal to v over a, and then t is equal to 3.25 times 10 to the 6th meters per second over 6.62 times 10 to the 13th meters per second squared. Then I got 4.92 times 10 to the negative 8th seconds. That's the answer for that. Yeah, I didn't have too much trouble with this problem. I just wasn't really sure where to start at first, but then once I figured out that I should use this, because not a lot of the equations, or none of the equations really, have acceleration in them for electricity, so I guess it did make that kind of easy to figure out what to use. But anyways, yeah, and then I had a little trouble figuring out the directions because I'm not very good at that, but drawing a picture helped a little bit. And yeah, just, also, I picked the kinematic that didn't have time because it says it starts at time is equal to 0 seconds, so couldn't use that. Also, I was able to log back into my account on my iPad. I just had to update it, so it works on WebAssign now. Alright, that's all.